Hello again. This is Lynn Turback, and this is the second in a series of screencasts on CS111 Lecture 5 on Booleans and Conditionals. At the end of the last screencast, you were asked to define 3 Python predicates. Let's take a look at some solutions for those. For isFreezing, we simply check to see if the temp parameter is less than or equal to 32. And that's a Boolean, so this is a predicate. It's a function that returns a Boolean. IsLongName is similar. We check the length of the name string and see if that's greater than 20. IsVowel is a fair bit more complicated. Here is one solution to IsVowel. We have 10 tests, each one of which, like this first one, compares S to a single vowel, where we check all the 5 lowercase vowels and all the 5 uppercase vowels. So there's 10 checks, and we combine those using the OR combinator. So if any one of those is true, isVowel will return true. But if none of them is true, isVowel will return false. We can simplify that a bit by using the lower method on strings to lowercase the string s. So this takes the lowercase value of s and names it in the variable L, and then we only need to check L against 5 possible lowercase vowels. An even simpler version of isVowel3 is this one, where we first check to ensure that the length of s is 1, and then after lowercasing s, we use in, which is a substring membership, to see if that string is a substring in A-E-I-O-U. And so it's very important that we check that the length of s is 1. Otherwise, we would have, say, a 2-character string AE as satisfying this. But this is another version of this method, this function predicate, and it shows that there's many different ways to define a predicate correctly. Let's take a look at a solution that does not work. Here is something that students are often tempted to try because it sounds like English. What we'll do is we'll check to see if L is equal to one of A, E, I, O, or U. And the problem here is that this entity, which is the result of the OR, it's not clear what it is. We'll understand by the end of this lecture exactly what this means. But testing L against the result of ORing together these 5 different characters does not do the right thing. The main context in which Booleans and predicates are used in any programming language is a conditional statement. In Python, the conditional statement is introduced by the keyword if, and so it is also known as an if statement. The if is followed by a Boolean expression, an expression that evaluates to true or false, which is also known as the test expression of the if statement. If that test expression is true, then all of these indented statements below the if are evaluated. These are said to be in the then branch of the if statement, also known as the then arm. And if the Boolean test expression is false and there is an else clause, then all of these indented statements down here are evaluated, and they are said to be in the else branch or else arm of this if statement. It's important to note that in Python, any time before we have an indented set of substatements, that we need a colon. So after the Boolean expression, we must have a colon here, and after the else keyword, we must also have a colon before having any of those statements. As an example of the if expression in action, let's consider an absolute value function. So this is a function that takes a number n and returns its absolute value. One way to do that is to use an if statement whose tests if n is less than 0. If n is less than 0, what it will do is it will negate n and return it. So for instance, if we have the number -3, we will negate -3, thereby making it positive, and return a 3. The else clause here will be reached in the case where n is greater than or equal to 0, and in that case we just return the number n unchanged. So this is an example where we have an if statement that has an else clause. As another example, we can rewrite the absolute value function not to have an else clause. Let's see how this works. So in this version of the absolute value function, we have two statements that are in the body. The first is an if statement that does not have an else clause. In this if statement, again, it's the case that if n is less than 0, we are going to return the value of -n, and return will exit out of the call to the absolute value function, so the second statement would never be executed. If in fact n is greater than or equal to 0, then the second statement in its body will be executed, and that will return n, and that's what will happen in the case where n is greater than or equal to 0. We'll return n unchanged. Because if statements are statements, they can appear in Python where any other statement would appear. For instance, an if statement may appear within the if arm or else arm of a conditional, and this is called a nested conditional. A very common pattern that we see is a case where the else clause of a conditional contains another if expression. What this means is if Boolean expression is false, then we will come and execute the else clause, which itself will execute another conditional, and that will test if Boolean expression is true, in which case we'll execute 3 and 4, and if both Boolean expressions 1 and 2 are false, we will execute statements 5 and 6. As an example of this, let's take a look at a function that, given a numeric age, returns a string which is a movie rating for that age. So we check to see if age is less than 8. If that is true, we return a g and we exit the function. However, if age is greater than or equal to 8, we now will try another conditional test to see if age is less than 13. So if this is true, it must be that age is greater than 8, but less than or equal to 13, and so in that case, we return the string pg. If age is greater than or equal to 13, we have yet another if statement that tests if age is less than 18. So we will reach this point if age is greater than or equal to 13, but less than 18, in which case we return pg13. And we reach this final clause only if age is greater than or equal to 18, in which case we return the string r. Now, one of the problems of these nested conditionals is that each time we nest, because of Python's indentation, we end up creeping toward the right. So if we have a very complex nested conditional, we end up moving more rightward and ending up coming up against the right-hand side of our screen, and that means we just have less room to maneuver in. So to deal with this, Python defines an alternative form of nested conditional called chained conditionals. So an if statement, in addition to having if and an else optional else clause, can also have as many elif clauses as we desire. And what the meaning of these is as follows. So in this particular if statement, if Boolean expression 1 is true, we will execute statements 1 and 2 and be done. If Boolean expression 1 is false, we will check Boolean expression 2, and if that's true, we will do statements 3 and 4. If both Boolean expressions 1 and 2 are false, we will test Boolean expression 3, and if that's true, we will execute statements 5 and 6. And if all of Boolean expressions 1, 2, 3 are false, we will then go to the else clause and execute statements 7 and 8. So using chain conditionals, we can rewrite our movie age example thus. And a nice feature of this is that there's no rightward creep. We can have as many clauses as we want, and our indentation level doesn't change. This has exactly the same meaning as the movie age example from the previous slide, except it just stays at the same indentation level the whole way. Okay, now we're going to ask you to get some practice with using if statements by defining some functions that require using if statements in their body. We'll ask you to define two such functions. The first is addArticle, and what this function does is it takes a string, presumably it should be a noun, and it adds the correct article in front of that string. So for cat, it should add a before cat, and for ant, it should add an before ant. And if it's not a noun, it doesn't make sense, but ignore that for now. It is important to consider, however, what this should do for an empty string, so think about that. And in order to define this function, it's helpful to know the following, that if you use the notation s sub 0, so these square brackets are pronounced sub, s sub 0 returns a string with the first character in s. And you'll probably want to use the isVowel function that you defined earlier as a helper function. So that's the first of two functions you are asked to define that will require use of an if statement. The second function you are asked to define is sumUnique. And what this function does is it takes three integer arguments. And what it is supposed to do is it is supposed to return the sum of those arguments that are unique. So anything that is replicated should not appear in the sum, but if the numbers are unique, they should be added. So in this case, 9, 5, and 6 are all unique, so their sum is 20. But in this case, only 8 is unique, so it should be returned. Here, only 5 is unique, so it should be returned. Here, with all 4s, none of them is unique, and so the sum should be 0. And so that is the second function that you are asked to define. So please go to the lecture 5 code.py file, which has skeletons for these two functions, and flesh them out using if statements and test them to make sure that they work. And we will discuss the solutions to these function definitions at the beginning of the next screencast.